For assignment 28, number 1, when I finally decided to use the loop rule, I found that the potential difference between points A and point B was 6 volts. So since between A and B is like an infinitely large resistor, that means it's impossible for current to flow in the circuit. So that means the voltage drop across the first resistor and the second resistor must be both 0, and so then the potential difference must be 6 volts for the loop rule to work. For assignment 28, number 3, the voltage drop of a diode is a property of the diode. So these diodes have a voltage drop of 2.5 volts. Since they're in series, the total voltage drop would be 7.5 volts, but it's impossible because there's only 5 volts coming from the power supply or the battery. So that means there will be no current. Since they're in series, the current through the first one must be equal to the current through the second one must be equal to the current through the third one, but that's going to be equal to 0 times the current through the original diode because there's no current flowing. For assignment 28, number 5, for part A, I forgot the units, which is amps or volts over ohms. So that's 0.0588 amps times the cosine of omega t plus 0.783. So then for part B, the voltage drop, the peak voltage across the capacitor, so Vc equals the current times DC, or the impedance. So the peak current is when the cosine of omega t plus the phase shift is 1. So then the voltage is 0.0588 amps times negative j over 2 pi times the frequency, and then multiplied by the capacitance, which is 22 microfarads. So this becomes negative 7.088 J, and then you need to take the magnitude to find what it would be measured. So that is the square root of the real part plus the imaginary part, each squared, and the real part 0. So the magnitude becomes 7.088 volts. For assignment 28, number 6, because V out is across both diodes, the voltage will be clipped at positive 0.6 and negative 0.6, creating a square wave. The positive voltages go through one diode, but only up through 0.6 volts. Then the negative voltages go through the other diode, but only up to negative 0.6 volts, thus clipping the output voltage. And this is because, as a property of diodes, these diodes have a voltage drop of 0.6.